Let's get reviewing right now. Thursday, you have quiz number 2. You see all the topics on the sheet I just handed out. Yes, I didn't put it good. Proofs are not on there because they're not on the quiz. Okay, but everything else listed there is fair game, including circumference and arc length, which I know is from quiz 1, but I got to pop a question or two on the review to review for that as well. Yeah. Oh, yeah, absolutely. Yep, to answer the algebra questions, absolutely. All right, every day, you know how it goes. We're going to review. Go right down the line here. Let's start with inscribed angles. Well, I already gave that one away. That was going to be one of my questions, which is what type of angle is this? This is an inscribed angle. Well, how do I know that? Let me open it up to you guys. How do I know that? Here we go. 28. How do I know ABC is an inscribed angle? Okay. I like the ending one. I'm not, because you can have a diameter and still be an inscribed angle. I could still draw this right here. That's still an inscribed angle. Okay, so even if it's a diameter, that's fine. But yes, all 3 points are on the circle. More importantly, the vertex is on the circle and the other 2 sides are what? Chords. The other 2 sides of the angle in an inscribed angle have to be chords. How do I find the measure of it? Let's go 16. How do I find the measure? Darn right. Measure is equal half the arc AC. Half the measure of arc AC. We're all good. Okay, that is one of 4 facts you should know about an inscribed angle going into Thursday. Second fact you should know, what pair of angles other than the verticals are congruent up here? Other than the vertical angles, give me a pair of angles that are congruent. 17. D and F, yep. Okay, so angle D congruent to angle F. Why? What are they? What are they? Get more specific. There you go. That's what I want to hear. Inscribed angles. Keep going, Teddy. Sorry. Drawn to the same arc. What do we know about them? Yep. We're all good. Okay, moving on. Angle C. What do you know about it? Other than it's inscribed. Get more specific for me. Angle C. 5. Angle C. 90 degrees. Right angle. Why is it a right angle? Here we go. What type of angle was it before it was a right angle? Okay, ready? Inscribed angles. Where's it drawn to? Diameter, I accept, or A. It's drawn to a semicircle. Either one I'll accept, all right? Drawn to a diameter / semicircle is what type of angle? I'll finish it. Inscribed angle drawn to a diameter or a semicircle is what type of angle? You just told me at the beginning. Right angle. Okay, all good so far? That's third fact you got to know. Fourth and final fact, give me a relationship. This is a quadrilateral inside a circle. Give me a relationship between a pair of angles up there. Here we go, 27. What's a relationship? Angle A plus angle C equals 180, and the same can be said for angle B and angle D. Opposite angles are supplementary. All right. Questions there? All right. And then Friday, we took a look at these bad boys. Name ABC. Name line ABC for me. Let's go. 23. Name line ABC. Tangent. How do I know it's a tangent? 19. How do I know this is a tangent? Only touches in one spot. Name point B. Name point B. I'm going to make sure we got this vocab down. 30. Name point B. Point of tangency. Watch what I'm about to do. That's the center. Drawn to the point of tangency. What's happening now? 18. And what happens when I draw it to the point of tangency? Radius drawn to, where did I just draw it to? Drawn to point of tangency forms a right angle. Anything? Okay, now start checking your homework because now I'm going to start incorporating where this came up in the homework. Okay, where this was used in the homework. And the first spot it was used was question 20 you had. Question 20, I could use that theorem. Add something to my diagram, please. Here we go. 8, add something to my diagram.
There's a right angle at RST.
Yep, that's the theorem we just went over. Radius drawn to a point of tangency forms a right angle. Got it. How can I find the sides then? Using what? 28. How can I find side lengths of a right triangle? Pythag. A squared plus B squared equals C squared. Check your work. Give me a leg length. Leg length. 23, a leg length. X. Ooh, went to it right away. How do we know RS was X? It's a radii, and what do you know about the other radii? Any radii in this diagram will be X. X squared plus, give me another leg, 28, another leg length. 20. And then how about a hypotenuse length? 27. X plus 12, all squared. You're going to have this Thursday. Can you deal with this? This is probably the third time I think we've done this. Can you deal with that? X squared plus 400 equals X squared plus 24X plus 144. What's going to cancel out on both sides? X's are gone, and I'll leave it up to you to solve this right here. We okay with that theorem? Radius drawn to a point of tangency forms a right angle. We're okay with this little concept here. A lot of reviewing. Moving on. What do you know in my diagram? AB and CB are tangents, FYI. They're tangents. What do I know? 5, what do I know? Yep. Tangents drawn to the same point are congruent. Okay. This came up in the homework. 24, here's where it came up. You had to find X and then find the perimeter. All right, so let me ask somebody here. Number 2, there's 2X. We're here, never mind, Connor. Okay, that's 2X. What other one's congruent to it? 14, that is the theorem I just went over. These are two tangents drawn to the same point Q. So 2X was equal to 14, X was equal to 7. All right, so that's 14. I got a couple questions for number 6. If that's 17, name another segment that's 17. VS, yep. Then what's RV? 10. Name another segment that's 10. UR. And now I can find the perimeter. Two tangents drawn on the same point are congruent. Anything else there? I think that was it. Oh, one more. 27. How'd you figure out this one? Finding the length of X. No. This is number 27. Calm down. Okay? I haven't called on anybody yet. 22. What do you want to add to my diagram first? Fine. That all radii are congruent in a circle. There's 4. Need some more additions to my diagram. 3. Anything else? Right angle at R, yep. And at T. All right, so I have right triangles. It looks like I can do Pythagorean Theorem. All right, pick a leg. Pick one right triangle and pick a leg from it. 26, pick a leg for me. 4 squared. Plus, name the other leg. 19, name the other leg. X squared, yep. Even if we use this one, if that's x, how do I know that one's also x? Tangents drawn to the same point, congruent. Equals, oh, watch your mouth here. Hypotenuse, 19, hypotenuse. What's up? 9, how'd you get it? What's this? I know that's 5, but what about this piece? It's a radius, all of them are congruent in a circle, yep, and then 9 squared. We all good there? And then you solve it for x. Oh, the name actually lived up to the hype. Unlike a couple ones we've done in this year, this one did live up to the hype as in a challenge question. Just so you know, maybe you want to cross that word out and replace it with, it's on the darn quiz Thursday. Okay, there you go. So how do we finish this now? All right, how do I finish this? Find PQ. Well, first off, you should have been able to add something to the diagram based on the theorems we just went over about tangents. You should be able to add something to this diagram. What's point P and point Q called? Points of tangency, and what are R, P, and QS? Radii. When they meet, what's formed? Right angles. So I at least have right angles up here. Everyone's good. But I have no idea about these here. All right? Because it's not a rectangle. All right, that is certainly not a rectangle. I got 4 and 6 on opposite sides. So here's what we're going to do. I don't know. Anybody think they got this and tried it out? Did you make it? What'd you make? You drew another line in? Good, good. I am going to draw another line segment in. Here's why. I do want to make this bad boy up here a rectangle, and what's left over is going to be a right triangle. All right, watch. So I'm going to draw a segment in right now from the smaller radii, 4. All right, my best of my ability here, directly across. So right now, on top, I have made a rectangle, which you know, what about the angles of a rectangle? They're all 90 degrees, right angles, which means what about the one next to this one? What about the angle next to this right angle I just drew in? That's also a, so does everyone see the rectangle I drew in and a right triangle? Okay, keep filling in more values now for me that I gave you that. What about this piece here? What about this piece? It's a rectangle. What about this piece? 4. And what about this piece of the right triangle? 2. Okay. What about the distance from R to S? Well, what was this? This is a radii, which was what? 6. That's a radii, which was 4. So this will be 10. The problem is asking me for PQ. I don't know if I'll be able to find PQ, but what can I find that's congruent to it? The opposite side in the rectangle by doing what? Pythag on the right triangle. What's a leg of that right triangle? 2. The other leg? The other leg? The hypotenuse is across from the right angle. What's across from my right angle? 10. And then I'm off to the races. Okay, so easily again, you take the smaller radii, draw a segment across that creates a rectangle and a right triangle. And then I use all my properties of a rectangle and radii. Yes, Meg? Question? Ask away. Because like I said, that's not going to be a challenge. I'm not going to write the word challenge on there. It's going to be number 3 on Thursday. Anything you want to ask about this? Or, okay, I'll turn it over to the rest of the homework. I know I went over a bunch of problems already, but I didn't go over all of them. So are there any I did not go over that we want to touch upon? Meg? 18. Before I go back, just make sure. I don't think it's on this page. Nope. There we go. Too far? Probably need one more. Probably going, oh, do I have anything? Nope. Okay, 18. U, point of tangency. UT, radii. They meet a right angle. 7 squared plus x squared equals 11 squared. Round to the nearest tenth. All good? Yeah. Okay. Anything else? Okay. Let me take a quick peek. I'll be here all this week, FYI, if you want to buy and go over anything. Calculators, let's get ready to roll here. Before we start, because we are going to find a new type of angle in the circle, to the right of the circle I provided, to the right, I need you to draw your own circle with your own center, and I'm going to walk around. Please draw a central and an inscribed angle in that circle, so I am confident we can move on to a different type of angle. So the circle to the right, so right to the right of that circle I provided, draw yourself your own circle with the center, and I'm going to walk around looking at your central and inscribed angle. Draw your own circle with your own center. Then I need an inscribed and a central angle. Inscribed and a central angle in the circle you're drawing. A lot of different ways we can do this. All right, we can all do that, I'm pretty confident. Now we have one last type of angle inside a circle. Please now look at the circle I provided. And let's get our focus on angle ACB. Angle ACB, and I could have picked any of the four. I just picked that one. All right, central angle. ACB, is that a central? No. Is it inscribed? No. So there's one we are unfamiliar with. Good. I'm glad I got a little confirmation on that. Here is what I'm going to refer to this angle as. Not very mathematical. Not central. Not inscribed. But we are going to now refer to this as a floater angle. Why a floater angle? Because that's exactly what that vertice is doing, just floating in the middle, around inside the circle somewhere. A floater angle. Okay? All right, well, how do I find this floater angle? A little bit more involved than inscribed and a central angle. We're going to add 2 arcs up. We're going to add 2 arcs up. What 2 arcs are we going to add up? We're going to add up the arc that belongs to the floater. So I'm going to put its arc. So its arc plus its vertical angles arc. So we're going to add 2 arcs together. The arc that belongs to the floater angle and the arc that belongs to its vertical angle. Now you'll notice, why did he put so much space there? For a reason, because we're not done with the formula yet. You're going to add those and then take half of that sum, or AKA divide by 2. So go back up to ACB. It's going to be half of, you tell me the 2 arcs I have to add together to get that floater angle. ACB, what 2 arcs? So its arc, calm down. 29, what arc belongs to ACB? Arc AB plus its vertical angles arc, which would be 2. DE. Everyone see where DE came from? I take the vertical angle of the floater, that arc DE. Everyone all good? Take a deep breath. We okay? All right, let's apply it. I am going to tell you that this is not the center of the circle. Okay, so it's not 88, we're done. All right, that's not the center of the circle. Is it inscribed? Is it inscribed? No, but then it must be a floater angle. 23, what's its arc measure? 88 plus its vertical angles arc. 24. Do we have a 24? Oh, thank you. How about 12? What's its vertical angles arc? 86. Honors kids, why are we hitting up the calculator? You don't know what's halfway between 88 and 86? Moving up, number 2. I got 65 degrees. Number 1, is that a floater angle? I should actually, let me rephrase. Is that central angle? Okay, let's regroup. Okay, let's just rewind. Your number got called. Okay. 65 degrees. Is that a central angle? Is it an inscribed? So it's got to be a floater. How do you find that floater angle? You take half of what 2 arcs added. What arc belongs to 65? 100 degrees plus its vertical angles arc, x. All right, quick discussion. What do you want to do algebraically now to solve this? Could you distribute the 1/2? Yeah, go right ahead. Me, I'm not a big fan of the old 1/2 x. So I personally would like to get rid of the 1/2 right now. That's just a personal preference. You can distribute. If I do want to get rid of the 1/2 right now, both sides have to be multiplied by 2. Now, make sure we're all on the same page here. 2 times 65. Okay, great. That's $1.30. Okay, over here, when you multiply by 2, that's it. The 1/2 and the 2 are gone. It doesn't affect anything inside the parenthesis. Don't try to distribute the 2 or anything like that. Just the 1/2 and the 2 are gone. And I'm left with that 100 plus x. Move the 100 over. There we go. X equals 30. No issues? Floaters? Until now? This will be a very common sight to you from now on. Arcs, angles that are in ratios. All right, arcs, angles that are in ratios. So let's start off here. Anytime this year we've had numbers in a ratio, we've put x's with them. So what do you want to put on arc ABC? 2x. So however you want to label that, that's up to you. A to B to C is 2x. What's CD getting? 3x. Actually, you know what? I'm going to change that. I'm going to change it to y. Does anybody know why? Yeah, there's an x here, and it's not the same as the other x's we're putting there. So I'm going to put y's instead. 2y, 3y. What's going on DFG? A y. And then what about AG? 4y. Got it. And we're asked to find the value of that floater angle. Well, I'm not finding it until I actually know the degree measures of the arcs. So we have to take care of that first. Is there anything I can, there's a couple things I could do, but anything I can do with all these 2, 3, 4 y's here? 4, anything I can do here? Okay. We'll go with your diameter. A diameter creates a semicircle. So name 2 arcs that make up a semicircle up here. Okay, so one way I could get out of this is doing 2y plus 3y equals 180. A second way would have been 4y plus y equals 180. Or heck, if you want to go big dog, add them all up and set them equal to 360. Whatever you wanted to do. All right, so find the arcs for me. 5y in this case equals 180. Y equals, we got there, 36. All right, so I have this arc is 36. 2y is, let's see, 72. And if you wanted to go find the other ones, you can. Anybody know why I'm not going to bother finding 3y or 4y? I don't need it to find that floater angle. All right, what do you want me to do to find the floater now? Here we go, 22. How do I find that floater angle? Yep, 72 plus 36. Take 1/2 of that sum. Halfway in between there, 54 degrees. Everyone all right? Sorry. Okay, we do have another one. All right. I don't think these are going to be very friendly. First off, a little history behind these types of problems where it's multi-part and there's just, look at that, lines just flying everywhere at you. I got tangents, chords, radii, diameters, all in the same circle. It's intimidating. 16 years of doing this class, I would love to come up one year with a name for these type of problems. Mrs. Gentile, who teaches way down the hall there, she used to call these Big Mama circle problems. I don't know. I mean, I refer to them as big dogs. I don't know what to refer to them because I don't like multi-part circle questions. That doesn't give it like a zip to it. Okay, well, we can think about it. All right, we don't have to make a decision now. All right, moving on. One at a time here. AEH. Everyone find that arc? A to E to H is 110. However you want to label that. A to E to H, 110. AG. A to G, 80. And the ratio between AE to EH, okay, what am I putting on AE then? 2x. And what am I putting on EH? 3x, good talk, yeah. And then everybody please stop. With these type of problems, I do not want you to go to parts A, B, C, D, however many there are, and start trying to answer them. The key to success on these problems is knowing all the arc measures. That's where you have to start. Forget about what I'm asking for in parts A through whatever. I need you to try to find all the arc measures in degrees, because if you can do that, chances are pretty high you're going to get the rest of the problem correct. So that's what I need your help doing right now. Can you help me find any of the, I got an 80, I got that 110, but I need to find all the pieces like EA, EH, HB, BG. I need to find all those arc measures. Can you help me out anywhere to get all those arc measures before we start playing? 11, anywhere. What's that? 70. All right, we got a 70 here. How do we know that? AOB is a diameter. It creates what type of circle up here? Semicircle, 180. Everybody good. That's 70. Done. Where else can you help me out? 10. Where else can you help me out? GB is 100. Same reasoning. Created a semicircle. 180 degrees. We're good. We're getting there. The only thing I need help with, it looks like, is AE and arc EH. Can I get a little help there? 21. I like it. 2x plus 3x equals $110. 5x equals 110. What are we looking at there? X equals 22. All right, go back, plug it in. What's the arc measure for AE? 44. And for EH, 66. All right, let's go to work. We got all the arc measures. We should be good to go. And most of the time, when you find the arc measures, you probably answered the first question or two, just like we did here. Part A is what's GB? That's a hundo. First time that's been on some of your papers. EA. Never mind. Too harsh. Yeah. 44. All right, now we got work to do. EFA. Say these three in your mind right now with me. Is it a central angle? Is it inscribed? No, therefore it's got to be floater angle. So I'm going to take 1/2, and I need somebody to help me. What two arcs am I going to add up if I'm doing EFA? EFA. What two arcs am I going to add up? 5. What two arcs? Okay, can you give me the measures there? 144. Nice job. And that'll be an angle of 72. Please, everyone, hold up. Get in this habit. Put it on your diagram. You never know. You may need that 72 later on down in the problem. Okay? So that's 72. All right, what's part D? FEB. Whew, all right. Everyone take a look at FEB. FEB. Go through it with me. Ready? Central. No. Inscribed. Got it. It's an inscribed. And according to my rule, I'm going to take half of something. What arc belongs to FEB? 27. What arc belongs to, FEB? Which is how long? Or what's the measure? 100. So we're going to take half 100. That's going to be 50 degrees. And then let's see if I can get anybody on part E. OHD. OHD. Don't say a word if you think you know it. OHD. It's not central. It's not inscribed. And somebody, well, hold on. H is on the circle, so why isn't it inscribed? Great question. What has to be the two sides of the angle to be inscribed? They have to both be chords. And I can tell you OH and HD are certainly not chords. So is this one we just say, nah, it was a good shot. Good try. I don't have it's not inscribed. It's not a floater. It's not central. So I can't find it. Baloney. You can find this one. Hello, Maggie. Yeah, you're darn right. No rule needed. 90 degrees. Why? Ready? What's OH? Radii. What's DC? Tangent where those two meet. Got myself a right angle. All right, this one here is going to be on your own. I'm going to write the answers up here. I just want you to, you may overlook this and not read it, but AP, segment AP is bisecting angle BAC. That might be helpful here. So you and your group try to find the arcs first, and then answer some of the questions below. They're giving you the three angles in triangle ABC. Talk it over with your group. I'll have all the work up here.